Testing. Okay, I should probably start soon. Okay, I should probably. Okay, I guess I'll start now. So as you can see, the problems are not necessarily sorted in difficulty order, and as you can see, they clearly are not sorted in difficulty order. By the way, Wolfram Alpha randomly generated a permutation for this. Okay, the first question, I hate non-int. You are given a sequence of positive integers and you want to find how many non-empty subsequences have an integer average. For subtask 1, the answer is obviously print 1, so please grab subtasks. For subtask 2, every subsequence other than the empty one works. So you just have to print 2 to the power of n minus 1, and you don't even need to do the fast exponentiation because n is only up to 100. For subtask 3, you brute force all the bit masks because n is up to 20, so 2 to the power of n can pass. So as you can see, here is the code. It's quite simple to just brute force over all bit masks, and for each bit mask we check if it is valid. For subtask 4, let's say that there are m terms that we choose in the subsequence. So we just need to find the number of subsequences of length m such that their sum is 0 mod m. So we let dp of ijk be the number of ways to choose j elements from the first I elements so that their sum is k mod m. Eventually we want the sum to be 0 mod m, which means that it's a multiple of m. So it is easy to see that this is our transition, and our answer is just dp nm0. After that, we apply this for every possible value of m. So here's the implementation. This is the main part where we compute the dp and then we return dp of nm0. Okay, should I move on? Okay, sorry, I was muted just now. So anyways, you are given two subsequences S and T, and you want to count the number of ways to pick a subsequence from each of them, so the two subsequences are equal in value. And if the set of indices used are different, they count as different constructions. For subtask 1, clearly if the subsequences are non-empty, then it does not work. So the only subsequence is the empty subsequence. Sorry, I was muted just now. So anyways, you are given two subsequences. Okay, sorry. So in other words, you just need to print 1 for subtask 1. For subtask 2, you brute force all the bit masks, so you find all the subsequences of S, and you store the count of each subsequence in a map. And for each subsequence of T, you then count the number of subsequences in S, which are equal in value. So here we iterate over all bit masks for the subsequences of S, and we push them into this, and after we compute the subsequence, we update the count, which is a map. For each subsequence in T, we then count the number of subsequences in S which are equal and increment the answer by it. So the complexity here is O of 2 to the power of n plus 2 to the power of m. Subtask 3, we just skip. For subtask 4, you let dpij be the number of ways to pick a subsequence from these elements, which are at the first I elements of S and the first J elements of T, such that the subsequence includes both Si and Tj. If the Si and Tj are not equal, then it's 0 because the last elements of the subsequence will be different. If they are equal, then dpij is the sum of dpkl over all k less than I and l less than j. However, this is too slow because it runs in O of n squared times m squared. To speed it up, we can use a 2D static sum, so we can compute each dpij in O of 1 time. So here, after we read in the input, we store a variable for the prefix sum of the two-dimensional grid as well. So using this, we can compute dpij, and we also update the prefix sum for the two-dimensional grid using the same method, using the principle of inclusion and exclusion. After that, we just need to output the prefix sum of nm, which will be the sum of all dp values. The third problem, between two arrays, you have to calculate the number of non-decreasing arrays C, which are between these two arrays. For subtask 1, obviously C is equals to both A and B, so you have to print 1 again. For subtask 2, you can brute force in product of bi minus ai plus 1. This, by the way, is the number of possibilities for each ci. For example, one way to do so is by representing each value of ci with 3 bits. So you use a bit mask of size 3n. And if you forgot to take mod or memorize, you would also get this subtask. Here is one possible implementation, which runs in 8 to the power of n, or rather maximum of a to the power of n. So we use this bit mask to brute force over all possible values of c, since c is from 0 to 7. And from this bit mask we can calculate the corresponding value of c. After that, we just need to check that it's valid, and if it is, we increment the answer. For subtask 3, let dpij be the number of possibilities such that ci is equals to j. So if j is not in this range, the dp value is 0. Otherwise, it's a sum of dpi minus 1k, because this value of k is ci minus 1. So here is the implementation for this dp. As you can see, we brute force over all k from 0 to j and increment dpij by dpi minus 1k. So for subtask 4, as you can see, we got that dpij is a sum over all k less than or equals to j of this. But then this can be stored using a prefix sum. So using a prefix sum, we can find each dpij in O1 time. So here is how it will look like. So we set dpij to dpij minus 1, and then increment it by the number of ways where ci equals j. So ultimately we'll have the number of ways with ci less than or equals to j. Okay, for question 4, index times A, you have to find the maximum sum of I times bi, where b is subsequence of sequence A. So please ignore subtask 1. For subtask 2, you brute force all big masks again, and then you just calculate the corresponding answer for the subsequence, and then you take the maximum possible answer. For subtask 3, let dpij be the maximum score if you choose j elements from the first I elements. So dpij is maximum of dpi minus 1j, which represents not choosing the ith element, and this should be I minus 1j minus 1. Sorry. So this represents choosing the ith element, where j times ai is the corresponding value you get, and after that you only have j minus 1 other elements to choose. And you output dp of nm because you are choosing from the first n elements and you are choosing m of them. Here is the dp as you can see. And yeah, done.